I hope you all enjoyed Hot Potato. Something that I want you to think about as we continue with notes is, have you ever been outside and the air seemed to feel sticky, maybe wet? And especially for you ladies, you probably noticed that when the air is sticky outside, it can make your hair super, super frizzy. Well, what causes this? Humidity, something that Greenville knows all too well from our hot, humid summers. So humidity is simply the amount of water vapor in the air. So if you ever look up the weather or you watch the Weather Channel, it may tell you that there is an 80% humidity for the day. Well, that's saying that the air is 80% full of water. So that would be very, very humid. And then you might look like this little rabbit up here. My hair gets super frizzy when it's humid, so I do relate to this picture a decent bit. Another word to make sure that you are familiar with is saturated, is completely full. So if the humidity is 100%, that is when we would say that humidity of the air was, or the air was saturated. So if the humidity was 100, the air would be completely saturated. Then you are very likely to get rain or some form of precipitation, because if it goes over 100%, that means the air can no longer hold that water vapor, and so that water vapor has to go somewhere. So that is humidity. Relative humidity is a form of humidity. This is what you see when you look up the Weather Channel. This is just saying the amount of water vapor in the air compared to what it could hold at that particular temperature and that particular pressure. So aka the percent of how full the air is. The fact that it changes with temperature and pressure is something that we will look at in just a little bit. Because if you change the temperature of air, you're drastically changing the formation of the air, and same with your pressure. So if those two things change, it will end up changing your relative humidity. So relative humidity is simply how full the air is of water, and we always write that in a percentage. So I'll give y'all a second as you finish writing that down. Okay, I'm going to move on. If you're still not done writing, then we're just about to pause the video on the next slide so you can get the notes from the partner then. So one thing that I want you to discuss with your group is, if you lower the air temperature, does this cause an increase, or lowering the air temperature causes an increase in relative humidity? What I want you to discuss is, why is that? And then if you raise the temperature, that causes a decrease in relative humidity. And I want you to also explain, why do you think that is? So not only do I want you to discuss this with your group, but this is something that is also a part of your notes. So make sure you write this down, okay? So write this down, and then when you're done writing it down, discuss with your groups, and you can go ahead and pause this video. This diagram is simply showing you again what I already showed you from the video. You have your different temperatures of air. Instead of using beakers, they just use columns. So as the temperature got higher from 23 to 74 degrees, the rectangle got larger because the air has expanded, making more room. And as that happened, your relative humidity went down each time because the water was taking less space. So that's just another visual for you. The next slide is also a visual. This is just showing you your warmer air versus your cooler air. So the little brown circles are representing your air molecules, or the gas molecules. Within the warm air, they're more spread out, and then you can see with the cold air molecules, a lot of them have condensed, so this air is very, very dense, and you can see how there is less room for water vapor between all of the molecules. So just another visual in case that helps you. So how do we measure humidity? We have looked at a few different weather tool instruments, with your barometer, your anemometer, your wind vane, and we all know thermometer. Well, now we have another one called a hygrometer. So a hygrometer, you can think hydro, this is just something that measures the humidity in the air. However, we have a particular type of hygrometer that we look at, and that's called a psychrometer. So if I am asking you what tools measure humidity, you can say hygrometer, or you could say psychrometer. So you need to make sure that you know each of those, because you don't know what answer choices you could potentially have on a test. The way a psychrometer works is you have two thermometers that are next to each other. One has a dry bulb, one has a wet bulb. I know that this says dry bulb, wet bulb. You can kind of ignore that. Just know that hygrometer and psychrometer is a type. But one has a dry bulb, one has a wet bulb. Some are called a sling psychrometer, where you would actually spin these both thermometers in the air, and you would see at what temperature the water evaporated, and that tells you the temperature or the humidity of the air. Now, I doubt that you will ever see this on a test, but there's a potential that the NCFE could give you a chart and ask you to read based on the psychrometer, what the relative humidity or the dew point is. Now, I don't think that will be that common, but it definitely could come up, and it is a very simple thing to do. I'm going to show you just very quickly, but if you have any questions, just make sure that you watch the video on how to calculate humidity and dew point, and it will explain it further. So here you have two graphs. So if you ever came upon this on your NCFE and you saw a chart for dew point and a chart for relative humidity, and you saw two thermometers, then you would instantly know this is a psychrometer. So this is what the question would ask, and it would either ask you for dew point or relative humidity. I know this can look super intimidating, but if you can read and just move your finger across in a straight line, you've got this. So let's take a look. The first thing that you're going to do is simply read what the temperature on the thermometer is. So it tells you which one's the wet bulb and which one's the dry bulb. So the temperature of the dry bulb is about 22 degrees Celsius, and the temperature on the wet bulb is about 14 degrees. And you can see that over here. So again, we always read on Celsius, not the Fahrenheit side. So 22 degrees Celsius is where this number is coming from, 14 degrees from there. The next thing you do is simply subtract these numbers. So 22 minus 14 equals 8 degrees Celsius. So there, just a little bit of basic math. So far, not too bad. And let's move on to our next step. The next thing that you do after you have your depression, or the difference, which we already figured out was 8, is you just find that on the chart. So if your question says, what is the relative humidity, and it gives you a picture of those two thermometers, then you can actually just read what this chart says to figure it out. So it says dry bulb temperature. So you find that on here, which I'll show you in just a second. So you just literally read that temperature off the thermometer. And then here it tells you the difference between the wet and dry bulb temperature. Well, if you're thinking, well, how am I going to remember to subtract? This told you to subtract, because finding the difference means to subtract. So you'd find your dry bulb temperature, you find the difference between it, and then you just see where they intersect on the chart. And that's what this is showing. So the dry bulb temperature was 22, and then your difference was 8. So you came up here and you found 8. Over here you found 22. You saw that they intersected right at 40. So your relative humidity was 40%. That's all you did. And again, you don't need to memorize this. You simply need to read the chart, because if it tells you to find the difference between the two things in the picture, subtract the two, as long as you know difference means to subtract. Find your dry bulb temperature based on what the picture says, and you just intersect them. So as long as you can read a chart like this, literally read the chart and follow instructions, you will be perfectly fine. So I wanted to go over that just in case it pops up on the NCFE. But like I said, I don't think it will. It's not that big of a topic. Okay, so now we are going to make sure that you have a good understanding of relative humidity and dew point. With no notes and no talking, so this is completely independent, I want you to write a definition of what dew point is and relative humidity. So everybody needs to close your notes now and put them away. No last glances at your notes to try to remember what it is. Just close your notebook completely and move it off to the side. Okay, so again, with no notes and no talking, you by yourself are going to write a definition of what dew point is, and then you're going to write a second definition of what relative humidity is. I want you to do this without looking at your notes because I want you to quiz yourself and see what is your actual understanding of it rather than just copying it off of a page, because that's not going to help you at all. So you'll write those down to the best of your ability. Once you have done that, within your table group is when you are going to compare your notes. So with your table, you can say, this is my definition of dew point. Everybody reads theirs. This is my definition of relative humidity. You can all read it to one another. And then as a group, you'll combine the little pieces of each definition to create the best possible definition you can. Because if one person, maybe they had a really good dew point definition, but not the strongest relative humidity one. Or maybe they started off really strong, but they were missing pieces. This is where you as a group can see what each other was missing and piece together the one whole good definition. You're then going to share that one good best definition as your group with the class. So that way we can make sure we have a good class definition based on the things that you have said. So I'm going to let you go ahead and pause this video while you work on that. Now that you have the class definition on the board and hopefully a good understanding of dew point and relative humidity, I want you by yourself individually, no talking, no notes, all that stuff, to write a summary about how relative humidity and dew point are related. In that summary, I want you to include what happens as you increase and decrease the air temperature and why that occurs. So you're going to look at how relative humidity and dew point are related, and then include what happens as you increase and decrease the temperature and why that particular thing is occurring. So again, you're writing this by yourself, no talking, no notes. You can use the two class definitions that are on the board. This needs to be on a separate sheet of paper. And this will be something that we are going to continue to work with and check. So make sure that you are writing as legibly as you possibly can. And I will let y'all pause the video while you work on this.